Welcome in, folks. Rob Mountford and John Kilby here with you again today. John's chosen not to put his webcam on, but hello there, John.
And g'day, everybody. Hope you're going well.
No long intros today, as we've got a lot to cover off in concrete basics, where John has kindly condensed a full day's Resene training session into today's webinar. It's unlikely we'll get time for questions today. However, as always, please do type them in and we'll come back to you following the webinar. Righto, I'm going to shut my webcam down now and we'll crack into it. So all yours, John.
Thank you very much. Good afternoon, everybody. Glad to have you here. So basically the purpose of this presentation today is give you a basic overview of concrete in all its various forms to help give you, to be honest, a basic understanding of issues that we come across on building sites all the time. So the more we understand it in a simple term, the easier it's going to be. Don't forget, all of this is going to be available to watch later and also download from our site. Now, just get this thing working. Here we go. A lot of what you're going to see today is actually from the Concrete Basics, a Guide to Concrete Practice. This is also available to download and available from Cement and Concrete and Aggregates Association of Australia. It's a very, very good booklet and it's free to download, so it contains a lot of handy information. So let's look and talk about what basically concrete is. And concrete is made by mixing cement, water, coarse and fine aggregates, and the odd admixture, etc., etc. Just so we know, cement is not concrete. Cement is a component of concrete. So concrete is all of those that we just talked about. It's the end product, in other words. So the aim is to mix all these materials in the correct amounts to make it easy to transport, place, compact, and finish. And once it's set and hardened, and give you a really, really good, strong, tough, durable product. So that's the basics of what's in it. The relative amount of each of these materials affects the properties of the concrete, and that's the key thing, and we'll come back to that later on today. Now, when you order concrete, it's up to the cement and concrete guys and the specialists to work with you for what properties you want. A good example of that is, again, the cement powder is basically the glue that holds everything together. And there are different types of cement. So generally speaking, most of the time we use the general purpose type cement, which is your GP. But sometimes you need high early strength in certain construction phases. I'll show you one of those later. Or you need a low heat cement. And what that means is not when you're in Siberia casting concrete. What it means is the chemical reaction when concrete cures releases heat. And if you've got a large mass of concrete, like the Clyde Dam, for example, and you poured too much too quickly, you'll get too much heat within the mass. All right, so that's what low heat cement's for. Sulfur or sulfate resisting cement, that's a classic for your wastewater pipelines and storage, etc. And shrinkage limited cement, if you're doing nice floors and you're going to polish them in a kitchen or in a building. Concrete's renowned for shrinking and cracking, so that helps reduce the amount of shrinkage that occurs. Now, again, each type of cement will produce concrete with different properties, and that's something you talk to your concrete supplier about, but it's nice to know there are different options there to help give you some guidance. Now, we talked about aggregates. Now, they're quite important when it comes to concrete. So we've got coarse and fine. So coarse can be crushed rock and gravel and your screenings, etc. And fine is your sort of sands and crusher fines, etc. Now, aggregates need to be strong and hard to help give the concrete its properties at the end. If you use weak or flaky or crumbly rock or sandstone, etc., it's just going to weaken the concrete. So it needs to be tough and durable to stand up to wear and tear and weathering and all of that, and chemically inactive. You don't want it reacting with the concrete. And it's key to understand that fresh concrete and the cement are highly alkali, and it's part of the reaction as well. So you don't want to be interfering with that. It needs to be clean, no different to before you put paint on, you need to clean the surface. Well, if you've got dirty stones or sand, then the cement's not going to bond very well to it. So at their plants, they always have clean aggregates, and if they're not clean, they wash them. And then they also need to be graded, because you don't want them all the same size. You don't want them all too small as well. So a good mixture of some medium-sized ones and the odd big one and some small ones helps give you a more uniform mix and strength of concrete. And if you want flow, often you'll use round aggregates, and if you want hardness or strength, you often use the angular ones or a mixture of each. So again, the concrete people will help advise you on these sorts of things. But what we're starting to see is quite a bit when it comes to the technicalities of what goes into concrete in the first place, and just having a basic understanding behind that helps you make decisions better. Now, the key thing with water is it's pretty simple. If you can drink it, you can use it for concrete. And that's an adage that's been used in the concrete industry for many, many years. What it's trying to say is don't use seawater or salt water for concrete. It causes degradation and especially corrosion of your reinforcing steel, etc. That's about it with water. It's not highly complicated on that. Now, proportion and mixing is a key point. A concrete mix is designed to produce concrete that can be easily placed at the lowest cost, and it's got to be workable and cohesive when you're actually placing it, so it doesn't fall apart, in order to harden up and give you good durable concrete. And it's called the mixed design. And what they do is when they're designing the concrete, they consider the environment that it's going to be exposed to, how it's going to be placed, how you're going to actually get the concrete there, etc., etc. Now, proportioning is deciding how much water, how much aggregates, how much cement, etc., etc., that you're going to put into that mix. And again, the concrete technicians work this out for you, but that's why when you're talking to them, you can't just order concrete. They're going to ask you lots of questions. Where's it going? What properties do you want it to have? And they can work with you to help change these properties. So the proportions of each of these materials in the mixture greatly affects the properties of the concrete, whether it's wet or dry. And they're measured by weight, because volume's not as accurate, all right? So everything in concrete is done by weight. And here's a good example of ratios. The water to cement ratio. So if you want strong, so concrete strength is measured by MPa, and the stronger and denser the concrete is, the higher the MPa, which is good for you because that makes it stronger, more durable, and reduces water transfer through it. So you can see the graph down below that you've got 35 MPa concrete, and you've got a 20 kg bag of cement there, and you chuck in a couple of buckets of water. Now, if you actually have the same amount of cement in your mix, but you put in more water, and it's not by a lot there, you can see how quick that MPa drops down, and then further to the right when you put in more water again. So we don't want to add, we only want to add just enough water to concrete to get it to react and make it transportable. Here's a couple of good graphs. Remember, these are all from that little booklet that you're going to be able to download at the end, so you don't need to take notes at the moment. So you can just see that strength goes up when the cement content goes up, and strength goes down when you add more water. And somewhere in the middle of those two is what you call the water to cement ratio, which they work out for you. And again, just remember, if you add too much water to it, it's going to decrease its strength. And what strength is all about, when you think about it, is what sort of properties do we want from that concrete? We don't want it to wear away from the weather. You know, we need, especially when it's on floors and bridges, we need to take an incredible amount of loading, and we want it to be around for 50, 100, 200 years sort of thing. So The strength of concrete in a hardened state is usually measured by the compressive strength or the compression test. So again, jumping up and down on it with good concrete is nice and strong. However, strength and durability are affected by compaction. We're going to talk about that in a minute, which is when you're pouring concrete, we want to make sure we get rid of any air that's been, you know, when it's been in the cement truck mixer and poured on site and all that, gets air trapped in it. And if you have air in the concrete, that creates spaces in the concrete, so it reduces its density and it reduces its strength. So compaction is critical to get the good strong concrete that we want. And also, which we're going to go into a bit more detail as well, curing. So curing is keeping the concrete continuously damp for a long period, and that helps it cure and get its strength. So we just mentioned what is compacting, or how is it actually done. So when we're placing the concrete and it gets air entrapped in it, we put a vibrating probe into it and move it around in a certain technique and sequence, and that helps bring all the air out from the sides and the top, and it helps the concrete settle and become more denser. And that's done when and during the concrete placement. Okay, so it's still mobile and it's easy to get it out, etc. If the concrete starts to stiffen, it's too late to compact it then. So that's why, if you've ever been on site, you see a concrete truck turn up, it's all hands to the pump, and everybody jumps in to do their bit because they've only got a certain amount of time to get all this spread out and compacted in the way they want it to be. And remember, if we compact the concrete well, then we will get a denser, stronger, and more durable concrete. And the off-form finishes, that's the form work that holds it all in place when you're doing it, will be much better as well. All right? So we're trying to get rid of any trapped air. So, sorry about that. So here's another example. Again, we talked about concrete being, you can jump up and down on it, and it's strong and durable and that sort of way. So we talk about its properties, its high compressive strength. But normal concrete, if you just poured a big slab and just left it, has very low tensile strength and very low shear strength. But if you put your rebar or your reinforcing steel in to the concrete, not only do you increase the compressive strength of it, but you also increase the tensile strength and the shear strength. Hence, that's why we put reinforcing steel in the first place. All right. And here's a good example, because here's the top right-hand side there, everybody. There's a little picture of a concrete bridge, and just pretend there's a big truck or something driving over it, and right in the middle. So now, if you look at that bridge, we've got two sorts of loadings on it. Is on top you'd have the compression, which the concrete's very strong at, but on the bottom side of that, you would actually create tension, and the concrete's trying to break itself apart. So hence why we put the reinforcing steel in the first place, is that helps handle the tension part of the process and gives it more strength. You can actually see this in real life. All you gotta do is get a king size Moro bar or Mars bar, depends which brand you like, and take the wrapper off and hold it and just bend it the same way as you're looking at that bridge, and you'll see it compress on top, and you look underneath the chocolate bar and you'll see it tear apart. So there's a good example of compression and tension, and also an excuse to buy a chocolate bar. So there you go. Now, just a couple of things of reinforcing is, just because you put the reinforcing steel in doesn't mean to say it's going to stop cracks, but it helps control them and reduce them. And it also reduces how many control joints you need to place in the concrete when you're doing big slab areas or big floor areas, etc. And we'll show you some control joints shortly. Just of interest, in that little picture of the bridge at the top, if you've got compression at the top and tension down below, the question would ask yourself, well, where do I put the reinforcing steel, or the position of it? And the simple answer is you put it in the lower part because you don't need it in the upper part because that's just compression and concrete handles that by itself. But in the lower part, because there's so much more tension there, of course you put the reinforcing steel there to gain the advantage of that. So that sort of covers the reinforcing position, as it's important where we do put it. And for those that have never seen this before, is you have what's called bar chairs or rebar chairs, and they come in different heights. And so you can rest all your reinforcing at different heights or different spacings around the place. So handy to know. And remember, reinforcement doesn't prevent cracks, but it helps control them and reduce them. And we're going to talk a little bit about concrete cover. What that statement means is the reinforcing must have a certain amount of concrete over the top, because concrete, when it's fresh, is very, very alkaline, and under a very highly alkali environment, steel won't corrode. It just can't. It gets passivated under a highly alkali environment. So if we have enough concrete covering over the top of it, then it's going to last a long time. But if you don't, and you only have, for any reason, the rebar's in the wrong place, you don't have enough cover, which is the thickness of concrete above it, then it can corrode and crack and do all sorts of things. So here's a good example. Again, this is in the booklet. Let's look at outside where the dog is. We've got 40 mil cover on top of the reinforcing, and also don't forget the ground, moisture can come up from the ground. So you've also got some reverse cover if you want to look at it from there. We've placed the rebar for this picture example in the middle of the concrete. But if we look inside, we've got a nice concrete floor there. It's nice polished concrete where the cat's sleeping there. You've only got 20 millimeter cover, because so the reinforcing steel is a lot closer to the surface. That's to help reduce cracking, because we wanted a nice looking concrete surface. And also it's not outside in the rain and everything else, so it doesn't need as much cover. So there's a couple of reasons why they've done that there. And don't forget, on the inside there, we've got our plastic sheet down to help the water, stop any water or vapor coming up through. So you get a lot more control inside than you do outside. So it's just a good example, especially for those that are new to concrete. And we talked earlier about control joints. What are they? They are planned breaks in the concrete, which allow it to move a lot more and help prevent random cracking. And we'll show you a couple of those later as well. So whether the isolation joints or control joints, the whole idea is we need them. So you can talk to your concrete guys and help them work with you so you can plan where to put them. And then you can, in some cases, you can actually make them look really good as part of a pattern, or it's meant to be there. So enjoy it and take advantage of it, take control of it, and have them looking good. So that's basically concrete 101 in 10-15 minutes, if you like. Takes a little bit longer than that, but let's have a look now at concrete floor slabs and specifically issues that we can have with concrete floors. We're talking commercial buildings, garages, and all of that. We paint a lot of concrete floors, and I'm just going to cover off some hints that we need done right to have a good, sound, hard surface. So again, compaction when we're laying that floor is critical, and I can't go over this enough, because we need a good, hard, strong floor. You start driving trucks and forklifts with heavy loads over these things, or machinery on top of it, needs to be compacted well, so we'll get a nice dense concrete floor. Otherwise, there's an example in the corner of concrete, a big concrete slab there that hasn't been compacted well, especially in that corner. You can see how open it is, but how strong do you think that is? What's even worse with that is if you look up a bit, there's actually a column, a steel column base on that corner, which is taking the load of a 2- or 3-story building, and it's as weak as anything on that corner. So that's straight out incorrect compaction or lack of compaction that's caused that problem. Now, you'll hear concrete and people say it's in a plastic state, or it's a setting state, or it's hardening, or whatever like that. So just a couple of quick ones. Is the plastic state is basically when it's mixed and movable. So it's plastic, and you can pour it and you can spread it around and you do your thing. And then the setting state, that's when it starts to stiffen, and basically it's at that state where you finished all your compaction, it's starting to stiffen up, and if you walk across it, you just leave footprints and nothing else. So that's when, at that stage, they start doing some final finishing. We'll look at in a minute. And again, why it's so critical that things are done at a certain speed. In hardened state, it's after it's set, so you can walk on top of it, but it hasn't finished, it hasn't gained its full strength, and it hasn't cured properly, etc., etc. So it hasn't reached its full strength and durability, but it's when you can walk on it and not leave any footprints. So let's have a wee look at finishing, because this is actually quite important, especially when it comes to flooring. So what is finishing? And it's the spreading, floating and troweling the concrete, help densify the surface and further compact it, and as well as curing, etc., etc. So you got initial and final finishing. So the first thing the concrete guys do is they spread it all out, they compact it, and they just level off the finish, the top surface. You see them with those big trowel things, and that's it. Then they have to wait, and what they're waiting for is bleed water, which is any excess water is pushed out of the concrete. This is water we don't want. All right, so we need to wait for that excess water to come out before we do any more finishing, because if we start troweling on top of that, what we do is we push that water back into the concrete, and it actually weakens the surface. So we're in a hurry. How do you get rid of the bleed water? Well, the thing you don't do, I'll emphasize this again, don't do, and I've seen it myself, is people standing there chucking cement on top of it to dry it up. All that does is provide a weak layer on top of the surface, and it's a nightmare. So what you do is you lay a soft hose across the surface, one person on each side, and you just walk along and drag it along, and it removes the excess water. All right, as an example. You don't trowel it and push it back in, and don't throw cement dust on it to dry it up. So then you can start floating it, and that's where you're now floating it again, and you're working the surface with the trowels. And what you're doing with that is you're removing any fine stress cracks, and you're leveling it off even more. And when you look at it, there's your Kelly floating trowel. You've all seen those mechanical ones, etc. Is you're actually making the surface denser just by the motion of the trowel going over the top, and the trowel, the float, whatever you want to call it, going over the top, and makes it much more denser, so it's going to be stronger and harder. And you need that on the surface of the concrete, especially if you're going to have cars and trucks driving over the top, or if it's in the concrete in the house and a lot of people walking on top of it, you want it as strong as possible. And then down the bottom, once you've got it nice and strong and dense, they'll put in some grooves sometimes and finish off the edges to just round them a little bit so you don't have any sharp edges. The grooving, what it is it's a way of putting a line into the concrete so that any stresses when it's shrinking and curing and drying and all that, and hardening and all of that, hopefully go to those lines, so you can try to control where you might get cracking. So here's an example of some hand troweling, and also your machine troweling. So it's the same thing, it's just a whole lot of trowels on the bottom of the motor, and the guys walking around densifying that surface, etc. All right, so a lot of you have seen it, and now you know what they're doing. This costs more money, by the way, and what often happens is they just pour the concrete. This is especially on a house. They just pour the concrete, level it off, and walk away. And there's no way that you're going to get good, hard, dense concrete, especially on the surface, if that's what they do. So you pay extra for this, but you end up getting a better product. Now you can do all of that, and if you don't cure it properly, then you've wasted your money. So what is curing? Curing means keeping the concrete moist for a certain amount of time, and that can be anything from 3 to 7 days. And why you want to do this, if you keep it moist, the bond between the concrete paste, which is cement and water, and the aggregates just get stronger and stronger and stronger. And that increases the MPa and the hardness and everything else. If you don't do this, you don't get such strong, hard concrete. When to cure is you start commencing it once you've finished doing the final finishing on the concrete. And then what it gives you is less likely to crack, it's stronger, it's more durable, and it ends up with a surface that wears better and take higher loads, or the loads that you expected in the first place. When you order on concrete, you order it by the strength, and you want to get that strength. In order to get that strength, you've got to cure it properly as well. So the easiest way to cure is just with either a sprinkler or a sprinkler hose and a very, 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 very fine mist. And here's an example here. Just keep it down. That's all you've got to do. Just a hint on this one, because I've seen people do it. If you're doing a garage at home and they come and lay the concrete for you and then they leave, and you're a busy person, so the next day you're up early and you hose the concrete down to keep it wet, and you go away and you come back at night and it's all dry, and then you hose it again, that's not going to do anything. You need to keep that mist going for 3 to 7 days. All right, you can't let the concrete dry out. Now, if you can't do that because of water restrictions or something like that, there are other things you can do. You can cover it with plastic sheets. Now, that can give you different coloured concrete. You can get dark and light patches if you put the plastic sheet down, and you need to hold it down there. But at least it's still holding the moisture in the concrete and not letting it dry out too quick. Or there are what's called concrete curing compounds, where you can spray those on top of the concrete, and all it is a resinous type material that actually locks up the surface, has low vapor transfer rate, and it just holds the moisture in the concrete again. I don't like these as much as the old water mist, where, if you have water shortages, you've just got to use them. If you're going to paint on top of this, then we might have to then treat the concrete afterwards by removing it or make sure it's compatible with paint, all right? But there's your options, so there's no real excuse. And the question is, everybody says again, well, is it 3 days, is it 7 days? How long do you actually do it? The simple fact is, the longer you do it, the concrete just gets harder and stronger over time. So if it's a household job, they say about 3 days, but for better high strength durability or big commercial floor, one would argue you do it longer for 7 days if you can. And again, here's a nice little graph, simple to follow. Over time, you can see day 1, day 2, day 3, with cured concrete and non-cured concrete, that's the strength development. So if you look at that, you think putting a sprinkler on and keeping it damp or covering it with plastic is a good idea? I do, because the stronger it is, the better it is. And the longer it's going to last, by the way. So that begs the question, what is 28 days cure time? And we say it all the time, and you've heard people say, oh, concrete's going to be cured for 28 days, etc., etc. What it actually is nothing to do with strength and everything else. Earlier on, I said that concrete is very, very alkaline. Fresh concrete is pH 14. That's as alkaline as you can get. And over time, as it's curing and hardening and all of that, but over time, the alkalinity drops to 14, to 13, to 12, to 11, to 10, etc. And generally speaking, at about 28 days, and this is a very loose statement, but generally speaking, it's dropped down to a lower alkalinity or pH, around your 10s, 11s, and that's when you can paint it. Because stronger than that, the alkalinity can burn the paint. You've heard of alkali burn, or it burns the resin in the paint because it's just too alkaline. So when we talk about 28 days, it's nothing to do with hardness and everything else. It's to do with the alkalinity of the concrete, and it's to do with painting. So there we go. And let's have a wee look at some floor slab preparation, shall we? So you remember when I talked about finishing the concrete and making sure you get the bleed water off it, and you want to finish the surface well. Well, if you don't, then what can happen is a problem called latence. And latence is a weak, non-durable layer of material with cement and fine aggregates, etc. That's brought to the surface by bleed water. And again, if you don't treat that right, you end up with this very, very loose material sitting on top. Now that middle photo is actually my finger rubbing it on a concrete floor where the person had a paint adhesion problem. And I just showed them it's got nothing to adhere to, all right? So we need to get rid of that. Now, please don't confuse latence with effervescence. And effervescence is something totally, totally different. That's it there. What effervescence is it's where your concrete's not as dense, or you didn't put that black polythene down underneath it and you've got a groundwater problem. And the water comes up through the concrete and picks up any unreacted lines in the concrete itself, brings them to the surface, and they are very, very loose. But that's an indication that you've got a moisture problem from behind the concrete. And there's not a lot us paint people can do about that. There's a big difference between latence and effervescence. Latence can be avoided, and in fairness, so could effervescence. Could put the damp-proof membrane down first, like your plastic, and seal up the floor. This is a good test that we often use on concrete floors, and it's actually got it's a proper standard test, ASTM D4263 plastic sheet method. What it is a 2-foot square bit of plastic, and you stick it down on the floor, and after 24 hours look on the back of it, and if you've got moisture condensating on it, it means that you've got moisture stored in the concrete, so you don't want to be painting it because the paint's not going to adhere. So then you leave it and do it again until you don't get it anymore. All right, so it's a simple test. You don't need $1,000 moisture meters and all of that, but a plastic will do the job. So this is an interesting thing. In the old days, and anybody that's watching this that's over the age of 40 will remember we used to acid etch the floors. There's a couple of reasons why we don't do it anymore, or quite a few actually. One, it's hazardous because you're dealing with acids. Two, if you've actually got a lot of latence on that floor, then the best way to neutralize acid is with an alkali. So as soon as you put it on, it will react, but it neutralizes itself because there's so much latence or alkalinity on that floor, so it stops working. The other one is you've just finally got the floor dry enough to paint, and now you're wetting the living heck out of it again before you paint it. So it sort of defeats the purpose, and it's a mess and it's everything else. So we don't like using acid etching. It's not as efficient as what you think and causes all sorts of other problems, which we, to be honest, are a bit boring and we won't go into today. So what we do is, you've heard of diamond grinding or concrete grinding, etc. Here's an example. This is the floor at Resene. I was just doing it as an experiment to show people how to do it. So there's the old floor. We use the concrete grinder to remove the top layer, and then with commercial vacuum cleaner we suck up all the dust, and what we end up with is a nice sound floor, which is good to paint, gets rid of all of any loose material if there is there on top. There's just huge advantages. The other thing too with diamond grinding or floor grinding or concrete grinding, whatever you want to call it, is there probably isn't a town in New Zealand that doesn't have a concrete grinder available to come and do this job for you. So they are everywhere, and they can do different grades of grinding too. So if you're just going to put flooring on top of it, you just do an average grind. It doesn't matter if it's grinding marks. So you need to talk to the grinders and say what sort of finish you want, whether you don't mind the odd swirl in it or you want a high level of grind, right? So you can have a wee chat to them about that.
I'll jump in on this one, John. So we've created just a really simple guide that shows coating systems for the different areas that we generally strike. So residential floors, garage floors, and commercial floors. What we want to do is just put together a few of the common options that we have in the Resene range. There's plenty more, so we just chucked in the most common ones. And really, this guide's pretty simple to follow. What it shows you really quickly is for residential, you can pretty much do whatever you want in the areas of single pack or two pack coatings. Now, it gets a bit tricky when you get into garages and commercial floors, as you really do need to be putting on two pack epoxies or urethane systems. So we've got them noted there. We won't run through them, but what we'll do is show you in a couple of slides the main problem that occurs if you get your garage or commercial floor prep or coating systems wrong.
Thank you, Rob. And let's look at a two-pack epoxy floor system. Now, this is that called Resene Epoxy. And Resene Epoxy is a two-pack epoxy, but it's waterborne. It's been around for decades. I used to use it in abattoirs, in hygiene areas, fish factories, police cells, believe it or not, veterinary surgery clinics, you name it. And the advantage is it basically has no smell, but it's as tough as old boots. So there it is there, the two pack, and then we've mixed it up, and then we're rolling on the coat. And then left slide now, we've got the first coat, and it doesn't look that shiny because the first coat, after we ground the concrete floor lightly, the first coat we've actually thinned it 10% with water. And what that's doing is helping it soak in to the slightly porous concrete after we ground it, and really got a good binding on that floor. All right. Then you can see the second coat being rolled over the top, and then on the right hand side the third coat. If you look in the middle of the right hand photo, you can see how suddenly the second coat's nice and glossy, and the third coat, it's hard to see there, but it is actually glossier. So the coverage goes up, and you get your gloss, and the glossier it is, it's a tough and durable sort of thing. So just because it's water-based doesn't mean to say it's soft. This is the good, tough two-pack epoxy that we use. We have other ones too, and urethanes, but this is particularly popular on garage floors, and like I said, in hygiene areas and fish factories and food processing plants and all of that sort of thing. And this is your problem that we face often when we have poorly prepared garage floors, low-grade concrete, poor preparation, the wrong paint used, etc., etc. Hot tire pickup is the most common thing, and most of your tires these days, if you actually look at them, there's big flat surface areas with the ridges in between them, and you come in and you've got hot tires, and sometimes they're wet as well, and it's like a suction pad. If anybody's ever put two pieces of glass together and tried to pull them apart, it's almost impossible. It creates a vacuum. And the same thing here, and it just tears the paint off. All right, so these are common photos. If you did the right preparation and put the right paint down, you wouldn't get this problem in the first place. All right, so that sort of covers off floors 101, just very, very, very basically. Put good concrete down, treat it well, cure it well, prepare it well, put good coatings on, you don't get a problem. Now let's look at precast. Some of you call it precast, some of you call it tilt slabs. Let's see if we look at that. I'm not going to read all these words, but basically precast concrete or tilt slab is often produced off-site and then delivered to the construction site and just placed in position. All right, and precast panels or tilt slab, again, whatever you want to call it, are typically smoother and have a better finish than in situ concrete. And the only limitation really is the height of the crane or the power of the crane to actually lift them inside. So this is what I'm talking about. And some of the finishes you can get are just absolutely amazing. It's beyond belief what they can do these days with the precast concrete. So this is actually in a factory, and there's actually one in Auckland there. And the advantage of this is it helps them control everything, including the curing of it. So the advantage of precast factories is you really do get a good product. Here's an example of them getting ready with all the reinforcing steel. There's all the formwork. Here's another example of a pattern. I'll show you some patterns in a minute. And this guy's just spraying the release agent on it, etc., etc. Now back to the factory, there they are, and they're pouring into the formwork or mould, whatever you want to call it, and leveling it off. Quite often, the other good thing with these factories is they have the sides of the formwork, they put vibrators on them, and that can help when they're pouring it get rid of the air. So again, you get a really, really, really dense tilt slab. The other way of doing it, a little bit less control, but there's nothing wrong with this, is you pour the floor slab and you finish it nice and hard and smooth. And once it's reached its hardness, you start putting the formwork on top of it, spray some release agent around, put all your rebar in, and then pour it on site. So you literally got the floor down, that's all cured. Now you're making your walls, then you're lifting them up on site, just like that. And there you go. Such a fast, simple, easy way of doing it. Now I'm going to bring up something because a lot of you like to leave this in the raw concrete state. There's nothing wrong with that. And Rob will go over it later. But if your MPa is above 30, and that's the concrete's been dense enough and etc., and all been done correctly, then that stops water going through it. So you don't necessarily have to paint it. You can paint it for cosmetic reasons or other reasons, but you don't actually have to paint it for weather tightness. But Rob will talk to you about that later. However, you can get color variance like in these photos, and that's from many, many different reasons, and some of it's to do with the release agent that was used and how much was used and where it was used and the temperatures, and there's tons of different things. So concrete's concrete, but it can have different shade colors like that. Now, I don't have a problem with that, but if you do, you either need to talk to the concrete people, and they might not guarantee it either, or finish it and then just paint it to give you uniform color. But here's some defined finishes, and look how amazing that can look. And here's another one here, and that's all from molds. I think it looks amazing. The detail is unbelievable compared to even 20 years ago. And then this is another popular finish, which is aggregate rich, and then they polish it, and look how great that looks. So we talked about when it's in its molds or its forms, you've got to actually be able to let it release, and that's great. But now we've got some release agents on the concrete. So if you do paint it, we need to make sure we remove those. There are so many different types of release agents these days that you need the concrete people to tell the paint people how to remove it, because some of them just wear away, some need to alkali cleanse, some need to be solvent washed. So the concrete people need to be able to tell or advise you, and then you tell us what type is there, so we know how to clean it to make sure we can remove it, or the paint can actually come off. All right. Now, what is in situ concrete? So we've poured a floor slab, we've poured some tilt slabs. Now let's look at in situ. And to be honest, lots of words there. Let's flick through that. We're talking about when you're on site and you're actually almost like casting the concrete in its forms. And this is a good picture. This is overseas, and what in China, and what they're doing there on the left top is they put the columns up, then they put the scaffolding, put the forms all around, cast the floor, and as soon as they want to cure it pretty quick and get it nice and hard, and then they can take all that off, pour some more columns on top, and they just go stepwise all the way up. All right. And the one on the bottom right, look at how much rebar steelwork is in those walls behind that form in the middle there. It's an amazing amount of steel reinforcing in those. But it helps increase the strength and durability of the concrete and the toughness as well. Here's another example. The beauty is you can move the forms around, and just piece by piece you're constructing the building. Now, form oil, the classic with this one is, this is a guy just spraying it onto the formwork before they put more on, is the key thing is don't get it on the reinforcing steel. All right, it's just because otherwise the concrete's not going to stick to the reinforcing steel. But again, the release agent is exactly what it is. It helps the forms, or the molds if you want to call it, help not stick to the concrete and easily removed. Now, the funny thing is in the old days, the timber board finish, you'll see it on some 1960s and 70s buildings. I'm in Wellington, and there's some really classic examples of this. It was done because it was just cheap. But nowadays, people actually pay extra to get the timber look. So, and then you could paint it and make it look like that. So, but if you have rough surfaces, like you do on some of these timber looks, you can get more bug holes. And don't forget, when you're casting it, think about this, you've still got to vibrate it and you've still got to get that air out. And here's a classic example of where we didn't have the concrete flowing right and they didn't manage to get it to get to the bottom of the in situ formwork, and you've got this. Believe it or not, I've actually seen something like this in a building, and this building was 40 years old, and they pulled the wall cladding off, and we saw one of these. And the more concern there is that's actually a column which is load bearing. So therein lies the problem. But this is these days with skilled concrete places and concrete people around, this is less of a problem. But it's something that they have to deal with. And when we're talking about levels of finish, when you've got in situ concrete, we need a certain level, or we need to know what we think we're going to get, so we know what finish to specify and what sort of work we need to do to finish the concrete in the first place. So it's called levels of finish, and when you look at it, Concrete Association New Zealand, if you see the pictures down the bottom and the words at the top, but you can, that's in situ concrete, and you can see as you go from left to right, it gets better and better and better. Now, a couple of things. To get F6, which is your absolute perfect concrete, you're going to spend a lot more time in the design and placing and finishing of it to get that, but it's worth it. And you don't want to be getting the ones on the left unless that's an acceptable finish for you. But all those bug holes aren't the best. So most concrete specified in New Zealand and Australia is at least F4. And look at F4 there, so it's the fourth from the left. So it's at least that, because we can always patch up the odd bug hole, or higher. The problem is that in a lot of cases, it ends up at F3 or F4, which is lower than what, a little bit lower than what you specified. And you then have to fill all those holes, or you wanted a better finish in the first place. And that's where textured paints help hide some of those imperfections, and your filling and all of that sort of thing. So you need to have a good conversation with your concrete guys and the designers of the formwork, and sit down and tell them what finish you want and what finish you're prepared to pay for, and work with them to help get that. Now, you remember we talked about curing and keeping it, so wet for as long as possible, the 3 to 7 days, etc., etc. Well, if you've got formwork in place, you need to leave it there for a few days afterwards to stop the water coming out, the excess water coming out. So you need to hold it in place to keep the concrete damp so it gets its strength and cures well. So if you leave the formwork in place, that helps with that a lot more. All right, any excess water will just come out the top. So if you look at the CANS, which is Concrete Association New Zealand, they've got some guidelines on what sort of finish do you want and when to pull it off. Now, the earlier you pull it off also affects the actual finish you get. So if you look at this, the lower grade finishes, you could pull that formwork off in 12 hours. But if you wanted higher grade finishes, then you at least 2 days, if not 3. All right. So remember, the longer you can leave it on, the better it's going to cure, etc., etc. All right. So hopefully that helps explain a couple of things. I know we're rushing this, but there's a lot to learn, and CANS and all of that have a lot of training courses and a lot of information. And develop a relationship with your concrete guys, and work with them to help write the specifications and get the results that you actually want and your clients want. So it's worth doing.
Thanks, Sean. Now, just talking about CANS, when we're going to cover off some of the coating options pretty quickly here. And so when you ask your paint suppliers for a paint spec on exterior concrete or masonry walls, we're not making it up on the fly as we go. We do take guidance from the Cement and Concrete Association of New Zealand, or CANZ, and particularly the code of practice that they put out. Now, you can refer to this yourselves, and it's actually in the handouts for you to grab, or we can fire it to you at any time. What we've done is taken a few of the common sections out of it today just to show you very quickly, but please do have a full read of the code of practice yourself at some point though. So for precast and in situ concrete, they're typically deemed weathertight, as John mentioned earlier, at 30 MPa or higher. So you actually don't need to plaster or paint them. What we're going to do here is thrown in some little red boxes, and as you'll see through the coming slides, it just shows you the sections that we're commonly referring to. And in this one, it states really clearly there that weathertight concrete will provide weather tightness without the need for exterior plaster or coating. Now, this is the coating guide, and this is the one that we probably refer to most often when we're specifying. And what we're going to do now is just zoom in on the next slide into in situ and precast concrete for you. As you can see, the codes there, they're the, just quickly on those, and it states it clearly in the code of practice, but they're the weathertight, sorry, they're the wall type designation codes, and that's like the B1, B3, or A1, A3 codes that you see there. Just quickly, what that all means is A is masonry, B is in situ, C is precast, and then the number beside them refers to the type. So 1 is internal insulation, 3 is integral insulation. What that all means is that's your exterior walls. And now there's a little code in there as well that refers to the approved coating systems. And as example, 4.3 that we're pointing at there is just a standard pigmented or clear coating system that can be used. And we'll show you on the next slide a bit more info as we come. So again, what it says there, that where it was specified 4.3, standard acrylic coatings that are at least 80 microns can be used, and with a minimum of 2 coats to be applied. And it states it really clearly that it's standard acrylic coatings cannot be used on concrete masonry walls, and we'll cover that off in a few slides time as well. So again, another really simple coating guide that we've put together showing the Resene systems for in situ and precast concrete. Now this shows most of the standard acrylic, this shows clearly that it's not to apply standard acrylic coatings to masonry as well, as you see with the big red X's there. We'll flip through, now we're into masonry blocks. Just showing a few examples there of blocks, and straight into the coatings guide again. Now this is the same, and we're going to zoom in just on the masonry area for this one because this is actually quite different. This is where you do require weathertight coatings on masonry, and they're deemed to be high build acrylic or high build elastomeric and greater than 180 microns dry film thickness. Now in the Resene range, you'll generally see us specify 3 coats of X200 for a pigmented system, or 3 coats of XC700 for a clear coating system. Again, on this next slide, zooming in really clearly, clear coatings, sorry, this one just states again at 4.32 that pigmented or elastomeric high build coatings for exteriors need to be at least 180 microns. And now on this one, just a reminder that all clear coatings should be from the same supplier as you're taking them through, particularly on masonry. And we'll just flick onto the next slide that shows again where the difference is with clear coatings. So no permeability testing is required for pigmented systems. Sometimes we get asked that, but it's not required for pigmented systems. But the code of practice does state that it's required for clear coating systems on masonry blocks. So there's quite a specific test that's required in accordance with the AS/NZS standards, and Resene XC700 has been tested and meets the requirements of that standard. And again, just another nice simple coating guide that clearly shows that high build options at 180 microns or greater for both pigmented and clear systems on masonry. So we do have a number of our systems or our coatings named in there, but it's not all of them by any means, but they're the most common ones that you will see popping up in our specifications. And we can fire these coating guides out to you if you find them handy or you think they'll be useful in future. And now that actually brings us to the end. There's a bit of a rush there at the end with the coatings section. As mentioned at the beginning, if you've asked a question during the webinar, we'll come back to you in the next few days to answer those directly. Thanks for tuning in. Next webinar next month is Colour in Landscapes with Di Lucas, and we'll be including that in the follow-up email that'll come out tomorrow. So there'll be a link to register for that one. So do click on that, and we will see you next time. Thanks for tuning in.